So before we begin to learn about the different types of chemical reactions, we have to first look at what actually makes a chemical reaction happen. So what makes a chemical reaction happen is when you have two reactants that collide with one another. So it's all about how often and with what force sort of the different molecules are encountering each other. So there's different ways in which we can make this happen. One of the ways that we can make collisions happen is by increasing the surface area of the reactants. So if we were to grind the reactants up and have them be really small, they would have more surface area and therefore they would be running into each other more and more likely to react. We could also dissolve the reactants in water. If we dissolve the reactants in water, then they can move freely in the water and they can flow from one place to another, and that also increases the collisions that happen. When they're dissolved in water, we could also increase the concentration. So the more that we can dissolve and the more that we can put in the water of the reactants, the more reactants there are and the more likely they are to collide and then react. We could also heat up the reaction. So heating up the reaction actually causes all of the particles to move faster. So when we apply heat to something, it actually adds energy into that system, and the molecules or the ionic compounds, they start to move around a lot faster. And so when they move around a lot faster, they're going to be hitting each other more frequently and colliding with one another, which makes them then react more. Now, another thing that we could do if we're talking about gases, okay, is we could apply a pressure to a gas. So if we apply a pressure to a gas, the gas gets smaller, and therefore the particles then are closer together, and it actually makes the gas hotter when we do this, and so they're again moving a lot faster, which is going to make those collisions more frequent. So one thing to keep in mind about this is not only do these certain factors affect whether or not a reaction will happen and whether or not there's collisions between the reactants and they actually are coming in contact with each other, but they also would affect the rate at which the reaction will go. Okay, so let's recall this was way back from Unit 1, and since we're going to be performing a lot of chemical reactions, we got to remember how we actually observe a chemical reaction happening. So there are 4 different indicators that a chemical reaction is occurring. Number 1 is production of a gas, and typically we see bubbles, or you might smell something, and we're also going to perform something called a flint test or a splint test, where you actually see if the gas will how it affects a flame, and that's another way of determining if a gas is being formed. The second is a color change. Okay. The third is heat being or light being released or absorbed, and I'm going to talk a little bit more about that in a second. And then also the formation of a precipitate. So remember that a precipitate is when a solid comes from a liquid. So we are adding 2 liquids together here, and you can see this red solid powder forming. Okay, so those are going to be the indicators that we're going to look for as we're performing our chemical reactions in the lab. So let me just discuss a little bit more about the heat of a reaction. So studying the heat of a reaction is called thermochemistry. And a reaction can either release heat, okay, which is called exothermic. Exo meaning out, therm meaning heat. So in that case, the reaction actually feels hot. Okay. Now, a reaction can also absorb heat or pull heat into it, and this is called endothermic. And so it then feels cold. So endo means in, therm means heat. So let's look at just a couple of graphs that kind of demonstrate these ideas. Okay. So here we have a graph that shows the energy of an exothermic reaction. Okay. So remember, exothermic is the one where ultimately at the end some heat is being lost. Okay, so right here at the beginning we have our reactants, and they have some amount of energy. In order for the reaction to occur, okay, it needs to have a certain amount of activation energy, and where that energy comes from is the collisions. Okay, so if we heat things up, we add energy, and so the collisions will occur more rapidly, if we add pressure, or if we increase the concentration. All of those things are going to increase the energy that the collisions happen. So we need to achieve what is called the activation energy in order for the reaction to happen. Okay, so then the reaction occurs, and you can see here that the energy of the products is way less than the energy of the reactants. Well, where did that energy go? That energy left in the form of heat. Okay, so it released heat into the air. This is an exothermic reaction. Okay, now if we look at a graph of an endothermic reaction, the reactants have a very low beginning energy, and so they need a lot more energy in order to an activation energy in order for the reaction to actually occur. And once it occurs, then you have the products that have more energy than the reactants. So you can see here that they have then absorbed or pulled heat into the system in order to react. And so in this case, we'd feel cold. The reaction would feel cold because it's pulling energy out of the system, whereas in this case, the reaction would be hot. So just keep in mind these ideas when we actually start performing our chemical reactions in the lab.